All right, we're live. Last section of chapter 4, which means we'll test next week. Probably looking like around Wednesday. So what we're doing in this section is somewhat kind of what we've been doing already to some extent. We're just going to do it on a much larger scale. We're going to be solving equations, conditional equations, and they'll be exponential and they'll be log. And all we're going to be doing is using the tools that we've already learn the properties of logs, and then the fact that logs and exponents are inverses of each other. Um, and we're going to be doing a lot of this without a calculator, so our answers aren't going to be like nice integers. They're going to be in terms of natural log. So here's an example. Example 1, 3 to the x equals 11. That's a conditional equation, right? For some value of x, 3 to that power will equal 11. And we know that x just intuitively has to be between which two integers? 2 and 3. Good, because 3 squared is 9, too small, and 3 cubed is 27, too big. And because 11 is closer to 9 than 27, the answer should be closer to 2 than 3, yeah? 2 point something, right? Well, we're going to actually figure out what it is. So to solve this equation, since we cannot write 11 as a power of 3, we're going to take the log of both sides. The natural log of 3 to the x equals the natural log of 11. So this natural log, taking the natural log of both sides, is going to be a very important thing, okay? Now, why would we do that? Well, it undoes the log. Notice I could have taken log base 3 of both sides, but I don't want to do that. But once the natural log is there, then beep, that can go out front, remember? And that's the real power of logs. That's my favorite property. And now I have x times the natural log of 3. Well, natural log of 3 is just a number, isn't it? So how would I solve for x? Divide both sides by the natural log of 3. So x is the natural log of 11 over the natural log of 3. Or if we write it as a single log again, it's going to be log base 3 of 11. Either one of those. I like either one of those for a multiple choice answer. And if you're interested in what that's equal to, you could type it into a calculator. Are y'all interested? It's 2 point something. I'm not really even that interested in it. We know it's 2 point something small, and we have the exact answer right there. Either one of those is the exact answer. So, did you find it? What'd you get? I just see you happen to have one in front of you. It's approximately 2 point. And yes, you can use the log button with the base. You don't have to use ln. 2 point what? 2.182. Yeah, you said 2.1, huh? 2.182. There you go. That's right where we thought it would be. So natural log. So what we did there is we solved an exponential equation by turning it into a log equation. Okay. Now, that's a very typical method. We're going to be doing that quite a bit. But sometimes it's a little bit easier. If that 11 were like a power of 3, we wouldn't have to do it that way. This is called the GTBTS method, or the get the bases the same. Okay, basically it says if you have b to the x equaling b to the y, then x has to equal y. If you can get the bases the same on both sides, then you can equate their exponents. It's because they're 1 to 1. Exponentials are 1 to 1. Let me show you what I mean over here. Solve each by the GTBTS method. I got 9 to some power equals 27 to some power. Now it looks good, doesn't it? I got x's on both sides, not just on one side. It's a conditional equation. I need to find the value of x that makes that true. Well, can I write both sides as a power of 9? Not easily, no. And can I write both sides as a power of 27? No. But 9 and 27 are both powers of what? 3. So that's what we're going to do. We're going to get the bases the same, And the first step is to find that common base. And in this case, it's 3. So this becomes 3 squared to the 2x, and this becomes 3 cubed to the x minus 1. Remember, parentheses are your best friends when you're substituting. So this becomes 3 to the 4x, equaling 3 to the 3x minus 3. And lo and behold, we have 3 to the blob equals 3 to the blob. See that? The bases are the same. So you could either take log base 3 of both sides or simply just go to this step here, which is the same as taking log base 3 of both sides. You just don't have to write that. Okay, log base 3 of blob. You don't have to do that. It saves a step. It saves a line of writing. And now we're back in algebra 1. We can solve that, bring the 3 across, you get x equals negative 3. It's a systematic approach, an algorithm, if you will. Get the bases the same. GTBTS. Kind of fun? All right. Let's look at this one. It says to get the bases the same. Well, right now I have 100, which is just a constant, times an exponential 1/5. So I have a base of 1/5 over here. And on the other side, I have a 4. Ooh, can I write 1/5 and 4 as a power of the same base? No, I can't. And 100, what do I do with a 100? Take away the zeros. Yeah, I think that's a good strategy. Let's isolate the exponential piece by getting rid of the 100. Yeah, and then it should, if I'm telling you that it's going to work by GTBTS, it's going to end up working out nicely. So now that you divide through by 100 and simplify, hopefully it's a little bit more obvious. Can I write 1/25 as a power of 1/5? Yeah. So this is 1/5 to the x divided by 4th power, and 1/25 is the same as 1/5 quantity squared. And now I get x divided by 4 equals 2. So if I multiply both sides by 4, I get x equals 8. A systematic approach. Inch by inch, it's a cinch. Working straight down. Now, if you didn't want to do that in terms of 1/5, because I know some of y'all don't like fractions, here's another way to do it. You could have said that that's 5 to the negative x divided by 4th power, and then 1/25 is 5 to the negative 2nd. And then you get negative x over 4 equals negative 2, and guess what happens when you solve? You get the same thing. Yeah. So it doesn't always have to be just what you're given, as long as you can find a common base on both sides. And it has to be just that base and another base. Are y'all ready to try this one on your own? Or is this... You can just what? Do it together. Okay. Wow. Yeah. Where do we even start? Yeah. 16. If you look at all your numbers, look at those numbers other than 1. What do they all have in common? 2, right? They're all powers of 2. So once you realize that, that would be your first step. Go through and write everything as a power of 2. And while you're at it, if you can get rid of the radicals, that would also be good. So this is 1 over 2 squared times, that's 2 to the 4th divided by 3 to the x plus 4th power. And on the other side, I get 8, which is 2 cubed, but it's to the 1/5, so it's 3/5, all over 2 to the 1st to the 2x minus 1. That's step 1. What's that? Oh, well, then you're going to be using the natural log, which we'll do in here in a little bit. But the instructions on this one said to solve it using the GTBTS method. So again, if I tell you to use that method, you're going to be able to get everything as a common base. It is doable. Okay. All right. Now, let's go ahead and I'll bring this to the top, call it 2 to the negative second. And then over here, I guess I can distribute, huh? That's 2 to the 4/3 x plus 16/3. Oh boy, here's those wonderful fractions again. Like we started the year with, right? Here I got 3/5 minus 1. What's 3/5 minus 1? Yep, negative 2/5. Good. And that's to the 2x minus 1th power. What I'm trying to do is get a single power of 2 on one side and a single power of 2 on the other. So really all I'm doing is I'm simplifying both sides separately like I did in the beginning of the year, like two separate problems. All right, now when I'm multiplying, what do I do with this negative 2? We add it, right? Because we're multiplying. So I need to add like terms. So what is negative 2 plus 16/3? Well, gosh dang it. Negative 2 is the same as negative 6/3. So negative 6 plus 16? 10/3, yeah. And then plus 4/3 x. That's the left side. Who's afraid of working with fractions? No one raised their hand. Good. We're used to it by now. And then over here, we're raising a power to a power, so we multiply, so we have to distribute. That's 2 to the negative 4/5 x plus 2/5. And now we have 2 to the something equaling 2 to the something. So 10/3 plus 4/3 x has to equal negative 4/5 x plus 2/5. And now we're back like in advanced algebra 1 where we have a linear equation but it's fractions. You have two options. You either embrace the fractions or you eradicate them. I'm going to eradicate them. I'm going to multiply both sides by the LCM of my little denominators. What's the LCM of 3 and 5?
15.
15. Good. It's their product because 5 and 3 are what? They're prime numbers and they're also co-prime to each other. Very good. If you remember the word co-prime. Now when we distribute the 15, I'll divide first. 15 divided by 3 is 5. 5 times 10 is 50. Plus 15 divided by 3 is 5. 5 times 4 is 20. Well, that looks good already. Distributing over here, we get 3, that's negative 12x, plus 3 times 2 is 6. A lot more user-friendly. Now it's the shell game. Red Rover, let negative 12 come over, and we'll let 50 come over. So that gives us 20 plus 12, that's 32x. And negative 50 plus 6 is negative 44. And divide by 32. And we get negative 44, 32ths. And if we simplify that, that's negative 22 16ths, which when we simplify that is negative 11 eighths. Just enough space to get it all in there. And look at that problem right there. And I wanted y'all to do that on your own.
You had to give us like 10 minutes.
Yeah, and that would just be for y'all to write it down and stare at the first line. Right? But inch by inch, it's a cinch, right? We're not doing anything new. We're just combining these new skills. The problems are they're fun. They're tedious sometimes. These fractions, you gotta respect them. That's the GTBTS method. Getting the basis the same. All right. Now, example 3. It's an exponential equation. I have base E on this side, and if I divide through by 9, I get 39ths. There's no way I'm going to be able to write both sides as a power of E. No way. So what do I do instead?
Log it.
Log it. Very good. When you can't get the bases the same, you log it. So this is the natural log of the left side and the natural log of the right side. Now, on the left side, I'm going to expand it out. I have a 9, so I'm using property 1, natural log of 9 plus 2x natural log of e. And that equals the natural log of 30. But hey, wait, what is the natural log of e? The natural log of 1 is 0. The natural log of e is 1. Right, because it's log base e of e to the first. So that's 1. So I get the natural log of 9 plus 2x equals the natural log of 30. Now here's what you're going to notice is you work through these problems, you're going to have a lot of constants that are just numbers, but they're in terms of natural log. Don't worry about what those are equal to. Just know that they're constants. So I need to solve this algebra 1 linear equation by getting the variable by itself. So that's going to be a 2x, and then I have the natural log of 30, and coming across is the natural log of 9, and now it's negative. And then I just have to finish the problem by dividing both sides by 2. So the natural log of 30 minus the natural log of 9 all over 2. This is an exact answer. It's not the most fulfilling answer for us because we like decimals. We can comprehend decimals. So if you wanted to type this into your calculator, you could. I'm going to go ahead and spend the time to look at other different ways to write this. Dividing by 2 is the same as multiplying by a half. Yeah, and now I can actually condense those, can't I? Because it's the difference. So that's the natural log of 30 divided by 9. And I don't know why I used brackets there instead of parentheses. I mean, they're fine, but there it is.
She's writing a little hard on the board.
Yeah, she's really trying to emphasize a point. Don't divide by 0. Don't divide by 0. Right here. What's another way we could do this?
That's where the board is in that class, right?
I think so. 30 is 3 times 10. So it's 2 times 3 times 5. And 9 is the natural log of 3 squared. 9 is 3 squared. So here's another way we could do it. I could expand that in the top and say it's the natural log of 2 plus the natural log of 3 plus the natural log of 5 minus 2 natural log of 3 all over 2. Now, there's one last thing we could do here. Notice we have 2 natural log of 3 terms. And we can combine like terms. So that's going to be natural log of 2 plus the natural log of 5, bless you. And then what's 1 natural log of 3 minus 2 natural log of 3? Negative 1 natural log of 3 all over 2. Yeah. Now, I didn't simplify over here, but this could also be 39 simplifies to 10 thirds. And you could get the same thing. So lots of different versions of the same answer, right? Yeah. My favorite is this one. I like 1/2 natural log of 10 thirds. But let's look at that real quick. One last thing. What if I didn't want the 1/2 out front? Could I bring them back up? I could. And if I raise it to the 1/2 power, that's the same as doing the what with it? Square root of it. So that answer there, bless you. Bless you. I guess she's using a staple gun.
I think you should make a big scene and go over there.
Be like, what the heck? You're ruining my life. My education.
Yeah, you should start knocking back
No, no. If it were a student, I would. But it's Mrs. Smith. She's on our conference period.
Oh, must be getting heated.
She's decorating, I'm sure. Okay. Any comments or questions on this one? Someone's got to have a comment. Oh, I like that comment. Oh. All right. Letter B. 7 to the blob equals 2 to the blob. It's exponential. There's variables in the exponent on both sides. My bases are 7 and 2. Can we write 7 as a power of 2 or 2 as a power of 7? No. So who comes to the rescue? Log it. Log it. Natural log of 7 to the x minus 5th power. Natural log of 2 to the 3x plus 4th power. And now what do I do with the exponents? Now here's where you got to be careful. X minus 5, natural log of 7. How's that looking? Gross. Very good. Because I need my old friends, Mr. and Mrs. parentheses. Yeah. Yeah. Equals distributing, you get parentheses, 3x plus 4 times the natural log of 2. So we need parentheses there because it's more than one term in the exponent. Now, remember, this is where students kind of get confused. Remember, if I have the natural log of x plus 1, I cannot distribute it. I can't call it the natural log of x plus the natural log of 1. But if I have the natural log of 3, let's say, times x plus 1, this is just a number, right? We already talked about that. I can distribute that, no problem. This is good. Okay, so that's what I'm doing here. I'm distributing the natural log of 7 into x minus 5. It's not the natural log of x minus 5. So it becomes x natural log of 7 minus 5 natural log of 7. And by the way, we're distributing because we gotta liberate the x's. They're trapped inside now. We distribute here, we get 3x ln of 2 plus 4 ln of 2. Looking good. I've got it all expanded. Once it's completely expanded, you're free to start getting like terms together, right? So x ln of 7 stays on the left, and he invites 3x ln of 2 to come across, and he now changes his sign. On the right-hand side, we have 4 ln of 2 who's staying on the right side, and he welcomes negative 5 ln of 7 who is now positive. So just like we did in Algebra 1, variables on one side, numbers on the other. But now we're at a kind of an interesting crucible here, or crux, because I have two x terms on the left, but they're not like terms. I can't do like 5x plus 3x is 8x. But I still need to get a single x variable. And there's two of them. How do I do that?
Oh,
If you're at a loss,
exponent? No.
in this case, if you're at a loss, I would encourage you to say, F it.
Oh, factor it.
Factor it. Yeah, factor. X is a common factor. So that's the first rule of factoring. Let's factor out an x. And that leaves us the natural log of 7 minus 3 natural log of 2. And then that still equals all this on this side, which a copy and paste is a, ooh, that's nice to be able to do that. Couldn't do that 25 years ago. I was writing on a chalkboard. The only good thing about teaching back when we were writing on a chalkboard is I never had heartburn. Because every time you write, the chalk makes a little bit of dust. And like a coal miner, you're inhaling it all day long. And it's like taking Tums for antacid. But anyway, chalk. Now what?
Oh,
Isn't this whole thing right here just one big number? Yeah. So if I'm multiplying x by 5, how do I undo multiplying by 5? I would divide by 5. So I'm going to divide both sides by that. I'm not going to show it because it's a lot of writing, but I get x equals, and I get the right side, which is my numerator, and now it's all over ln of 7 minus 3 ln of 2. Wow. That's the exact answer. X equals natural log soup. Tastes so good. If you wanted to type that into a calculator, you can. You can. In fact, I'm going to do it one time just to demonstrate it. If you have one at your desk and you want to play along, I don't think it's worth getting up to grab one.
can we expand it?
Wrong.
You can expand it. No, never.
Ba-da-ba, Diego, did you have some good wassail last night? Or did you not even stand in line because they were too long?
Actually, I did. I got one little tiny cup because whenever I was walking in, there was a stand that was giving him out, and there was nobody there.
Oh, yeah. You just hit it right.
Yeah, and then like I walked another 5 feet, and there was like a 2-hour line.
Golly. Yeah, wow.
It was pretty packed.
All right, let's type this in. Alpha y equals, that's me. Y'all can do alpha x, right? 4 ln of 2. You got to be careful here when you're typing it in to close the parentheses. It opens it for you. Plus 5 ln of 7. Close that one. All over the natural log of 7. Close it. Minus 3 natural log of 2. Close it. Double check, triple check. It looks right. It looks good. Hit enter. Now I'm going to store that as x. I'm going to store that as x. Now I'm going to come up here and I'm going to go to the original equation. Where did it go? Yeah. Is there a mode that you can put? Is there a mode called prank mode?
Just get out.
Where did all my
We're facing
Oh my god.
No way.
Yeah, it's not showing up.
No, you're working on it. Maybe if you maybe you'll be able to see it. Bro got hacked.
Oh.
Okay.
Oh, it came back. Yeah. Wow. That was weird. All right. Let's type it in now. 7 raised to the x minus fifth power. Boom. You get that number right there. Really small. That's very small, isn't it? Yeah. That's 83 zeros after the decimal and a 4 after that. Well, if I type in the right side 2 to the 3x, and I've stored it as x, that's why I can say x, I should get the same number, right? I should. Oh, yeah.
Hey, Mr. Corky, could you expand it and then like add like terms?
What do you mean by expand it?
Like do the
It's already expanded, right? Because it's got plus plus. We could condense it. Do you want to condense it? Condensing it would be bringing the 4 up. You get the natural log of 2 to the 4th minus the natural log of 7 to the 5th all over the natural log of 7 minus the natural log of 2 cubed. And that gives you x equals the natural log of 2 to the 4th over 7 to the 5th all over the natural log of 7 over 8. Notice 7 to the 5th is kind of large, isn't it? And that's exactly why having it as 5 natural log of 7 is preferred. Yeah, so that's another version of the answer. I'm not quite as big a fan of that one because it looks kind of like a complex fraction. But does that make sense then? It was already expanded. But it was worth taking a look at it this way. And then all of your arguments, it's kind of interesting to see there that all of your arguments, your 2, your 7, your 2, and your 7, they're prime already, so we can't factor it and then expand it anymore. All right. Now, if you thought that one was fun, did y'all think this one was fun? Then you're really going to think this one is fun. Because notice this one has 2 bases again, 5 and 6, and they're co-prime with each other. They can be written in terms of each other. But unlike B, there's a coefficient on each side now, a 3 and a 4. Oh. All right. Guess what we have to do? Log it. Very good. You might want to write small here. Unless, you know what? Here's what I'm going to do. I'm going to copy this. I'm going to add a page. And yeah, right. And there goes all my work again. And I'm going to do it right here. I don't want to be restricted by the space. And I don't think I need to verify that anymore. So here we go. Natural log it. Both sides. Natural log it. You're going to have a quiz like on Tuesday, and you're going to have a question like this on it. Like this one. Not like the previous one, like this one.
How long is the quiz going to be?
I don't know. 50 minutes? No. 5 minutes maybe.
5?
You want to see? I'll show you I could do this in 5 minutes, even talking you through it.
That doesn't mean we can.
Well, I'm talking you through it. You're not going to have me to slow you down.
Maybe you should talk us through it during the quiz.
No. All you got to do is go to the worksheet and what? The P word. Study. Practice, practice, practice. It's kind of hard to study math because it's more as a practitioner thing. You got to practice it. But you'd get a check for that. Now I got to expand it out. So this becomes the natural log of 3 plus 2x minus 1, natural log of 5. So we just have this extra term here from the previous problem. And over here we get the natural log of 4 plus parentheses 1 plus x, natural log of 6. And again, we just have that extra term. So those 2 extra coefficients turned into 2 extra terms. And that's it. That's really the only difference between these 2 problems. It's just a lot of things to write down from line to line. That's really all it is. But now I got to get my x's together, so I got to expand it out, distribute. So the natural log of 3 plus 2x ln of 5 minus natural log of 5. And over here we get the natural log of 4 plus distributing. We get this. You do a problem like this on a whole page, you can like frame it and put it on your wall, right? In your bedroom above your bed. All right, we got to collect like terms. There's an x term, there's an x term. So the 2x ln of 5 is already on the left, you stay, and then coming across is the other guy, which is now x ln of 6. Everything else that is not underlined or underlined in red now, those are all numbers. There's 4 numbers now instead of 2. They all go on the right-hand side. So the natural log of 4 is there. Natural log of 6 is there. And now remember, when you bring these terms across, they change signs. So minus ln of 3 and then plus ln of 5. That's a real easy thing to mess up. You're just being quick, you're hasty, and you forget to change those signs. All right, now on the left side, I have 2 terms that have x in them, but they're not like terms. I got to get them together. How do I do that? Factor, very good. So I get x times 2 ln of 5 minus ln of 6. And over here, It's just all of this. And now it's going to happen for us, right? It's going to happen. All we have to do to solve for x is divide both sides by 2 ln of 5 minus ln of 6. So we get x. Stop here. Yeah.